guys, we're building an escrow. Guys, all right, so Escrow, Solidity series. I don't know when this episode's coming out, but I just did a Sepolia Ethereum test network, just small dApp build for you guys with React. So keep an eye for that. It kind of combines all the things of how to build with Solidity and deploy the contract to Sepolia's test network. But okay, so diving in, let's talk about today's deal on Escrow. And Escrow, what it kind of is you could have a person here, bank A, and person B or bank B, right? And Escrow is like holding the thing in the middle. So then you have person C, right? So person C, if you want to send money from bank A to bank B, you send the money to the Escrow, right? The Escrow is kind of the holding account. And they're like, well, did person B fulfill their commitments? Oh, I sent them $10. Did they send me the lemonade back? That's what PayPal is, right? They hold the money in Escrow. They wait until the product shows up, and then they distribute the money to the seller and distribute the product to the buyer. So Escrow is kind of that middleman. So let's kind of dive in. Let's dive in. That's a bird's eye concept of what we're going to build, or at least learn more about. So state variables. We have 3 parties involved in the escrow. Depositor, the payer of the escrow, makes the initial deposit, so person A, boom, into the escrow account, which will eventually go to person B, the beneficiary. The beneficiary is the receiver of the funds. They will provide some service or good to the depositor before the funds are transferred to the arbiter. Okay, so the arbiter is the approver of the transaction, this guy, the escrow, the guy in the middle or girl in the middle, and they alone can move the funds when the goods and services have been provided. So boom, funds go to the arbiter. This person needs to fulfill on their promise of, hey, I sent you the what's it called, the goods or the service. Boom, arbiter can give the money to the beneficiary. So for this first stage, let's create these addresses as public storage variables. Perfect. Guys, I just went on a run. I'm like out of breath. heads all lightheaded. The screen doesn't, my eyes are still registering a screen in front of me type thing. When you run really hard and you're like about to pass out, that's the feeling I have right now. So if I pass out on camera while learning Solidity, it's because I'm that stoked for it. So, okay, so let's do it. So create 3 public storage address variables for the depositor. Okay, sweet. So we're going to go public depositor, and we basically need to do that 3 times, and we're just going to swap out the term to beneficiary, arbiter, and boom, and that's that. So I think that works. Let's see. Just running the test. Nice. Okay, so moving on. Constructor storage time. Each time a depositor, arbiter, and beneficiary come to an agreement upon escrow terms, they can deploy the contract or deploy a contract. The depositor will be the deployer of the contract. They will ask the arbiter and the beneficiary for the addresses that those 2 parties have access to. Okay, so the depositor, boom, let's say I'm selling you guys something, or you guys are selling me something. Let's define. Okay. You guys are forget it. Person A is the depositor. Boom. We need to, let's see. So they're going to ask for the arbiter, this person's address, the escrow address, and the beneficiary's address. Okay, that those 2 parties have access to. Then the depositor will provide those addresses as the arguments to the escrow contract for storage. Ooh, boy. Okay, so this is going to get fun. So create a constructor like this, which takes 2 arguments. It's going to take the address, the arbiter. So we're going to do _arbiter. And then it's going to take the address for the beneficiary. So address, and beneficiary, like that. And then I do believe we want to go like this. Beneficiary, see Daisy, that. And then we want to do the same for the arbiter. Did that not work? Okay, cool. So what this is going to do is assign the arbiter, I believe, to the depositor. Well, let's read the instructions before I talk that this is logically working. The depositor is the address deploying the contract. So take this address and store the depositor in the state variable. So the depositor. Okay, so I think what I need to do is also say depositor MSG.sender. So that's going to be the person who the MSG is, again, that global variable that we have access to. So let's think about it. So the beneficiary is getting passed in as the constructor, so we know who that address is. We need it when we make the contract. And the arbiter, we also need that address as well. Those 2 are getting stored in this escrow contract, and so is the depositor, which is us creating the contract. Let's see if this works. Nice. Let's go. Okay, so now we need to fund the contract. It's time to fund the contract. So we've stashed all 3 of these addresses in the variables. Perfect. Now it's time to fund the contract. So the depositor will send some ether to the contract, which will be used to pay the beneficiary after the transfer is approved by the arbiter. Your goal Payable. Modify the constructor to make it a payable. Okay, I think that's all we needed to do. Sweet. Sweet, guys. We're crushing it. Cruising on through. So now we have this approval stage. After the contract has been deployed with the appropriate amount of funds, the beneficiary will provide the good or service. They are now secure in knowing that the money is on the way. Once the good or service is provided, the arbiter needs a way to approve the transfer. So we're going to need to be able to build a function called approve, I bet. So once the good is provided, the arbiter needs to fire off a function called approve, and that needs to transfer the deposit over to the beneficiary's account. Okay, this is going to get some dicey stuff. Let's add this mechanism to our contract. So function, funky tone, function approve. It's going to be an external function, and this function should move the contract's balance. Ooh, so address, let's see, this dot balance, I believe. So that's going to be the balance on this contract is going to get approved or moved, let's see, to the beneficiary's address, right? So how do we do this? How do we do this, right? Is that what we do? Just beneficiary equals, no, that's going to overwrite the beneficiary storage variable. So beneficiary, do we have access to everybody's balance? Is that a thing? All right, let's peek at the thing. Let's peek at the thing. Escrow. Okay, so, oh, boom, require. That's right. Okay, got it. I forgot, guys. I forgot. So we're going to go, let's say, bool, success. And we're going to say, is it beneficiary? Call, and we'll say value. And it's going to be this address. This is the variable where this address, this dot balance equals the contract's balance, and then we're going to require S. Okay, I think that's what it asked for. Fingers crossed. We did peek at it. We did have the cheat code. We did peek at it. We got her there. Okay, so let's just double check that one more time. So we want to approve the message. The arbiter can call this, so I bet we're going to modify it to say only the arbiter can call this or something like that. And that way the beneficiary can't call it, or the depositor maybe can't call it or something, or maybe only the depositor can call it as well. So, but as long as the beneficiary cannot call that, that's going to be very important, I bet. So that's my guesstimate on what's going to be next. Security. So there's only one address that called it. Guys, I didn't pre-read, I promise. So there's only one address that should be able to call this. It's the arbiter. This is their role in the entire transaction. Your goal is to build a modifier that only the arbiter can do this. So if anyone tries to call the approve other than the arbiter address, revert the transaction. So what I want to say is do a modifier. We may not even need it, but maybe it'll work. So only the arbiter can do it. So require, let's see, msg.sender equals the arbiter. And we'll put our little underscore there, and boom. Let's see. Fingers crossed. That was cool. That was pretty cool. Cool. I'm gonna give myself one of those little pats on the back. Okay, cool. So we're moving forward. So security's there, and now we need to emit an event. So okay, it's important for the servers and the front ends to be able to listen and index on the important blockchain events so that they can show the most up-to-date information to the users. True, that is very important. An event can be declared and emitted like this. So boom, we can build the event. My event is going to be this address is the event that's taking in. And guys, this is water in a wine glass. I love it. So our function can emit the event. We need to build the event, and then we can emit it, and then pass it, obviously, what's being emitted, which we've defined as an address. So let's create an event so it's easy for an application to subscribe to when the escrow is approved. So we'll make an event probably called approved. So create an event called approved. There it is. And I'll go ahead and put it up here. I like my events, I guess, to be kind of by the storage and state variables, which takes in a single uint parameter. And this is going to be the balance. Says sent to the beneficiary. I'm going to move my face, emit this event from within the approve function. So what we want to do is after this is all successful and we required this, we want to emit the approved, and I believe we also want to show this. I did not put a colon. There we go. Let's try. So emit approved balance, boom. Not satisfied, not going to do it. So takes in a single uint parameter. This is the balance sent to the beneficiary. Interesting. Why is it not? Do we need to do a uint 256 potentially? Let's try. Error left. Error A equals B, not satisfied the uint. Contract function. Guys, oh, you know what? you know what, my bad. It's going to be MSG balance, I think, because because when you call this, is it already sending the data, right? So when you send out the address value, by the time it gets to this function, it's not going to have that value anymore. So let's see. Technically, this might work. It might pass the test, but I don't think that's actually correct, because you don't want to emit it until it actually passes through. So let's take a look see at their escrow and what they did. So they have error not authorized. Okay. And then after it's done, they emit the approved balance. Okay. So this is what they did. They stored, because this is important. This is one of those key, just tiny things. We don't want to emit an event until this successfully goes through. So what we want to do is store the UN's attempted value, right? Something like this. And then we want to, so we can say sent balance, right? Something like that, right? Whatever you want to call it, but you want to store that up here first. Because like I said, if we can't store it directly in this after, because when we send this off, it's gonna clear out the contract. But we can't store this emit above that, because if we did that, then technically we're not guaranteeing that the value was sent. What if it did fail right here, and then we still emitted the event first? So if we put it up here, we're emitting the event first. But what if this transaction failed? Why would we emit the event? So this is how to get around it. Is some setup lists. Guys, awesome. And that's escrow. That's escrow in a nutshell. That was quick. That was awesome. So let's just go back over that one more time. We have our depositors, our beneficiaries, our arbiters. We have a constructor where we're setting all these things, and then we are modifying. And then we built the approve function actually, and then we're modifying that approve function so only the arbiter can do that, can approve this contract, and then we're emitting the event that approves the contract and doing that in correct order. So yeah, guys, thank you so much for watching. I will see you on the next one. Golly.